Hello and welcome to Tvaritam AI. In this video, we are going to understand data splitting and sampling. Now, the core idea behind any machine learning model is not just to perform well on the training data, but also generalize well on the unseen data. And that is why we need to split our data set to create the parts in our data set that are not already seen to our machine learning model. So we need to get better generalization. We also need to avoid data leakage. That is why we divide our data into three parts, and you need to do it carefully enough to avoid the leakage. We'll understand one by one train, validation and test dataset. Training dataset is usually the largest portion that is used to learn patterns. It is used to understand relationships between input and output by the algorithm, and it is the study material that your model is referring to understand the patterns. Validation dataset is used after training when we evaluate the performance of the model on the validation dataset and then try to tune our hyperparameters accordingly. So if you want to adjust your learning rate, regularization, model complexity, and check again what kind of progress you get, if you get better accuracy, if you get better results, you use the validation dataset. So it is an iterative loop where you train, then you evaluate on validation dataset, then you can tune a little bit more, then you can again evaluate on the validation dataset. Now, the test dataset is used for final evaluation. So the test set must remain completely untouched. We use it only once at the very end to get a true estimate of the real world performance. This is the unseen data that we are talking about, and after testing, we generally do not go back and tune the hyperparameters because then our model would be overfitting on the data. This is how we split the data into three parts. Now, techniques to split the data is also important because depending on the type of problem and the type of balance in your classes, we go with different types of sampling techniques. What are these? Because as we need to ensure that each data set is having a good representation of the original data, we need to choose very carefully the type of sampling techniques. For example, if your data set contains certain samples that are there in training, but the samples in evaluation and testing are completely different, then your model is learning something else and being evaluated on completely different things. So first case of sampling that we have is random sampling. This is where the data is split randomly and it works well for the balanced data sets. Second is your stratified sampling, which is usually used when the data is imbalanced. So it is specifically for classification problems. For regression problems, we do not go with a stratified sampling. So when the data is imbalanced, we want to maintain the same ratio or similar ratio, if not exactly the same, we go with stratified sampling. So if we have, let us say, fraud detection algorithm, and we have data about fraud cases and cases that were not fraud. So in this kind of problem, the fraud might be 3%, 4%, 5%, something less, while non-fraud cases could be 90, 95%. So then we need to carefully split the data in a way that the train test and evaluation train test and this validation dataset has similar ratio, and it should not be that all the 90% of non-fraud goes to the training, all frauds goes to evaluation, and then there would be a very big mismatch. Then we have time-based or top sampling in our software, which is used for data which has a temporal order, where there is a time series data or the order of the row contains some meaningful information. So it is not randomly shuffling of the rows, it is split based on order. If you have 5 years of data, you want to train on the first 4 years and evaluate on the 5th year, then time-based or temporal-based sampling is used. Then we have data split ratio. Now, once we know why we need to split the data and we know what kind of sampling technique to use, we also need to understand how much data we split for each of the data sets. So do you give more data to training? Yes, you give more data to training, but how much? Do you give a 95%, 80%, 75%, which depends on a lot of factors. It can depend on the data size, which is one of the major factor. Then it can also depend on the problem complexity and your domain, as well as some other things that you might want to consider given your objective. So ideal data split is dependent mostly on data side. If you have a lot of data points, like more than 1 million, you can give 99 to 99.5% of data to training, because with this large number of data points, even 0.1, 0.5% of values for evaluation gives you enough number of rows to test your model. As you go with lower data points, you need to give more percentage of data to your test and validation dataset because you want significant number of rows to evaluate your model. And you can see the typical splits on your screen, so you can follow the same pattern. You will also see this reference in the info section of the software when you would be implementing. But in case you have very few dataset, like if the data points are too low, one can skip on a cross validation dataset. Now this is usually not a good practice to do because you still want to tune hyperparameters, but there is an option to go for a 0 for cross validation dataset in case you want to skip because you have very few data points. So you just train and you then try to evaluate. Then we have training batch size. Now training batch size is something that is used only with models that are gradient based, like linear regression, logistic regression, neural networks, and does not apply to models like decision trees, random forest, gradient boosting, and other tree based models. Now type of these gradient descent are full, mini, and stochastic, right? So this training batch size will define how many samples are used before the parameters in the models are updated. So in these gradient based models, parameters are updated after a particular iteration. Now if you want to use the full batch, the full data, the entire data set to update the parameters, this is a more stable approach, but it can be slower and be memory heavy, so it will take more computational resources. Mini batch is one of the most common thing that we go for, so we can use batches from the data, like usually in the multiples of 32, not necessarily. We could go with 32, 64, 128 and so on. So this is faster, this is efficient, and this is a balanced approach. Stochastic gradient descent uses one data point at a time. So after every data point, we will try to update the model parameters. This is very fast, but it can lead to noisy updates. Now, going through a quick demo walkthrough about how sampling works within our platform. Once you are done with pre-processing, you select the model architecture type, you go to the data sampling option. Here I am dealing with diabetes prediction and my target variable has some imbalance, so I go with stratified sampling, and is diabetic is my stratification target. So is diabetic is the feature where the ratio of all the classes would be preserved in the train, CV and test dataset. Now here I will go with the 80-10-10 split depending on my number of values. So I have around 1500 to 2000 values and I go with the 80 for training, 80% of the data, CV, cross validation 10% and testing 10%. And here I will go with a mini batch where I will go with 64 as my training size, right? So you can go with mini batch, full batch, stochastic in case of these algorithm, because I have selected a linear algorithm. For decision tree, random forest, this is not an option that you will get in the software, and for regression problem you will not get a stratified sampling option because there is no class imbalance or there is no class when we are dealing with regression. It is a continuous value that we are trying to predict. Once I click on apply, this is applied, and then we can move forward with selecting our hyperparameters, training the model, and finally exporting the model as well as the accuracy report. Thank you.